Hello, folks. So this is, I think, part six of me solving LeetCode problem 1920, which is build array from permutation. And let's get started. So I was actually yesterday trying to understand what's the exact algorithm we're going to code. So initially, I was actually thinking about having index equal to 0, have a stop point hold value. This is basically the only point where we start and then probably go back to and stop and then move on to the next index. This is basically the index, right? Stop point index, and you can call it the stop point index, right? So there's a value the value at the index is negative, then we just keep moving forward, right? And if the index is equal to the value, then we just again move forward. So the thing is, I realized there are two kinds of stuff we do. First of all, this stop point index is needed only when you travel. For example, just go from something like you have, say, 111, and then you have an index 11, which is 1, right? So you basically are traveling, or if it has 16, you're basically traveling, and that's when you start the stop point. It doesn't make sense to have a stop point initially itself or a default value and all, because then you actually have to check the stop point, and you need this check of stop point only when you're actually traveling. When you're not traveling, for example, let's say your values are equal, index and the value are the same, you're not traveling. You're just saying, okay, this is the same, so we just don't do anything. Index is negative, we don't do anything actually. Index value, the value of the index is negative, we don't do anything. So only when you're traveling, which is where the value and the index are different, and it's the value is not negative, right? So you are going, and if it's negative, it means you have already gone to that place and they updated it and all that, right? So traveled, when I say traveled to or visited index, it means or a value, it means we've gone to that index, we've gone to that value, and we've changed it, updated it, and it doesn't need any updation. It's like the final output if it's negative, right? So now only during this we have to start, and it is a loop, as in it will somehow come back. I mean, it will come back, not somehow like there is a way, but I mean there's always a way, and there is some way or the other, and it will come back. And we proved this in our previous videos. So it will be like a loop, and it will come back to the stop point, and then we can move on. We can just um, get rid of the stop point. The stop point is needed only here to stop till here, and then we can just say, you know, we can just leave it, and it can go to the next value. We can just do index plus plus maybe, and then if the value is at the index is negative, then again index plus plus it will go on, right? So once it is done, so we get rid of the value. So stop point index will actually be local, and there will be a loop happening here, right? So we'll have a loop of sorts here, and say a loop, and before the loop starts, we'll actually say this, right? Um, and we'll actually say this is the stop point index is index, stop point index is value at index, right? That's all. And in this loop, we actually do this, right? So you notice that oops, you notice that we are actually we're changing the value of the index by actually doing this. So index and value are not the same. So we find out the nums of index, its values, nums of value. We put that. So now, right? So we basically say. Um, So we basically override the value at index, because this new nums, if it is not a new array, if it's the same array, then it's overwriting the value. This is a different value. We can just call it value. Uh, Actually, this is a different value. Yes. The whole thing is different. This is still value. Nums of index is still value because and the value of the index. So we just find out the new value. It's most probably a different value than this because of it cannot be. I mean, uh, what do you say? The value at this place cannot be value because it's already the value at index. There is already this value. Let's say this is 16 and this is index 0. So 16 is here. Nowhere else the value 16 can be present at any given index, even nums of 16, right? So cannot have 16 because already nums of 0 has 16. So once we do this, we say index is value, and then we go ahead and start doing this loop until I think we can say that okay. So next, let's say it's 1, 11, 11, 1. Like you go to 11 and then you say so now you basically have a loop where you go to 1 is the index, like something like if we give a example, 1 moment. So 1, 11, 11, 1. Let's say we start with this, right? 1, 11. We have 1 and 11 as a thing, and we finally say nums of 1 is 11 and nums of 11 is 1, so we just put 1 inside it, right? And then finally you go to 11, right? You go to 11 and then you say nums of index is equal to nums of index. So this actually, I mean, once you put 1, 1 moment, once you put 1 over here, like you say the index is basically value 11, so you go to 11 and you say nums of 11 is 1, nums of 1. This value you basically have to find out. So find out the original value, right? So in this case, you say this, right? Um, you might have to stop here basically because the index is still 11, it's not 1, right? Um, the value is gonna be different. Let's say this is nums of index 11, nums of 11 is 1. Nums of 1 is going to be something, and the value is going to be, we put 1 here. This nums of value alone, we have to check uh, if this index is part of, what do you say, get original value. We can just say as number and original value, right? Not updated or original. This should be the original value because in this case, nums of 1, when you update nums of 1, we'll actually be putting, like whenever you do this update, I think we have to also do a extra thing over here, which is, you know, do something like, I think in this case, it's supposed to be 1, 11, 11, 1. It's supposed to be 1 over here. But since we change it also, it becomes -2. And 11 is the value, right? 11 comes up here and we change it to -12. But you also do something like, so new nums, you also have to change it here. If the value is negative, okay. The thing is same. We actually have to do an extra thing over here, which is equal to, or we want to do something like we need to do, I think it was minus x minus 1. Y is equal to minus x minus 1 because just minus x won't work, just putting a symbol won't work. Because, yeah, I mean, you can also do something like plus 1, but you will never, I mean, yeah, you can do this also, minus x plus 1. 0 will become 1, 1 will become 0, right? That's interesting. 1 will become minus 1 plus 1 is 0, and 2 will become minus 2 plus 1, 1. Minus 3 plus 1. So not 2 will become minus 2 plus 1 minus 1, right? So it will be like 1, 0, minus 1, minus 2, minus 3. So for minus 4, it will be minus 3, right? Instead, I'm just going to put it as minus 1, right? So instead of making 0 as 1 and then putting uh, for 1 as 0 and whatnot, and then 2 as minus 1 and all that, I'm just going to put it as 2 will be minus 3 instead, right? So 0 will be minus 1, 1 will be minus 2, and whatnot. So this I'm going to do here. So I'm just going to say minus 1. I don't know if my just negation works, or we can just write it as minus new nums of index minus 1 to mark this as traveled to or visited, and right, traveled to or visited. Just put a visited, right? Um, then let's put this mark this is visited, right? Um, oh, interesting. Okay, or visited, and also say that what is it? And updated or gotten new value, right? So the above thing is for that, right? So we'll just say this, and this we need to do it here also. We need to do it even for this to mark this. So this will be separate maybe, right? The only thing here is we need to ensure that if the value, if an index is at stop point index, then we need to actually give the old value of that, right? So I think in this case, if the value is equal to stop point, we can just give the original, right? I'll just put that here. Um, if value equal to stop point index, right? Get the value first. We say value we already know, I mean, we know nums of index is value here. If the value is equal to the stop point index, right? Then we say something like this, right? No, this is for not equal, else this, right? Um, but if it is equal, um, then we'll say something like is equal to value, and then nums of value is basically um, it's basically nums of stop, not it's the stop point old value, right? So yeah, so you need this, right? Because nums of value will actually just be nums of index. Index will be, I mean, 11. So the nums at the value at 11 index will be actually 1. And for 1, the new value has become like something else, probably like minus 12 or something. Not minus 12, minus 2 or something, right? Because it's 1, so it's minus 1 minus 2. So instead of going into that, because it's already reached, if the so it's nums of value, right? So you need nums of value. Um, so we tell y as stop point is the old value or original value at stop point index, and we need the original value of nums of value, right? So we can actually write here this nums of value, but original value, right? Original, original. Just say that, or yeah, you get the whole drill, right? So because this has to be right, and this value nums of one will have like minus two or something, so you can't use that. Instead, you'll use the old value. And once you reach this, right, you can just say you can stop, right, over here. Once you reach this, you can stop the looping, right? You actually say now you finally say once you're done with this, you do this, and you say index is value, which is 1, right? So, and then you go back to 1, and then you check if 1 is, and this time you have to actually break out, right? You have to break once you're done though, right? So, yeah, if index equal to stop point index, we need to break, right? And that's it. I think good to go. And finally, so this stop index is needed only for this loop. We'll just use it here, right? And we'll just create it whenever we need it, right? And once we get out, we'll actually break break out of loop, right? And then you're done, and then you go back again to the code. Finally, so this is uh, you also check if so if value and index is negative, so you just keep moving on, right? Just a loop. This is all a loop. So loop, and you just say index equal to 0. So you just say this, and we loop through things, right? So you can just say this, maybe one, and yeah. Once you loop through this whole thing, uh, finally you say you go through this thing and you say and you make it actually index plus plus. What you do is you do the reverse of this, which is minus of this whole thing, right? Or you basically get you basically need this, right? So you basically do minus of the whole thing, which is x plus 1 and then minus 1. Uh, so minus of the whole thing, and then one moment, is it that? Minus x minus 1 minus 1 minus of the whole. Um, Actually, if you need to get this, you have to do, so add 1 and then negate it. So you'll have to do something, one moment. You'll have to do something like, and uh, and above algorithm will work when new nums and nums point to the same array, right? So here alone, what you have to do is, let us say, um, so if it's minus 2, you'll be like minus 1, and once it become 1. So yeah, this is what you need to do. Or you can actually just do this. This one is okay. So one moment. So if you need y, you basically start with minus y minus 1, same thing as this, which is minus x minus 1, right? Minus of x plus 1, and you need y, so minus y, and then minus 1. So minus y minus 1 works, or minus of x y plus 1. So this should just work, and you can just do index plus plus, and then you're done. Let's see if we can code this. So you start from number y, right? So you say value is negative, then go forward. Okay. So you don't do plus plus over every loop, it's because index is just gonna go around all the way. So of course index has to be less than length though, but you won't do index plus plus just like that, right? You do it only when it's necessary. And so now we will actually loop over nums, right? So that's what we do. Here also it's loop over nums, nums, right? So we just do if the value is negative index plus plus. Let's do that. We have, let's call this the index. I don't want to call it I. So index, right? Um, so value is equal to nums of index, okay? And now we say that if value is less than 0, then we basically go ahead and just do index plus plus and continue, right? We stop there. We say index plus plus continue, right? And if the index is equal to the value, then we just say, um, then you just say the value is that. If index equal to value, then you don't have to change really anything because you're just saying nums of indexes again value. You don't have to do anything because it's the same value index, and this is what the value was initially, and finally also it is the same. But you do have to do this. You have to actually ensure that you do this minus of this thing. So you can take the value and just do minus of value minus 1, or you can actually say minus of nums of index, but we've already done nums of index, we've gotten the value. So we just say nums of index is equal to, uh, we can actually just say value, or we can just say nums of index minus 1, right? Uh, aka minus value minus 1, right? So as nums of index, is like this. Is just, I mean, it's the same thing. So you don't have to really do anything. You don't have to continue here because, and you have to actually do index plus plus. Oh, looks like we can just do index plus plus here. Interesting. But you shouldn't do index plus plus. So we break at the stop point and then you do index. I think we can do index plus plus at the end, like over here itself. Right, let's see. We'll have to continue, but we'll have to do index plus plus, or else it will just keep happening. Like, let's say 0, the value is the same, 0 0, and it will just keep continuing. Right, so we have to do an index plus plus here also. Let's see how that goes. I think we can actually just keep doing index plus plus everywhere, but we'll confirm that. We do need the continue here, or else it will go ahead. We just don't want to do this. This can be an else if statement also if you don't want continue, but I would rather just put continue uh, than break here. We'll figure out how to actually do this, but or else it'll be if, else if, and then one more else if, so that you don't need continue. Or is if, else if, and else. Yeah, only one of these should evaluate, not all. So uh, you have your whole if index is not equal to value, then basically the else part of this. So if it comes to this, you don't even have to write the if, because if it's not equal, then you go here, right? So you don't even need a else, or if you don't even need a if to check. Uh, don't need an else of above condition or an if condition. Check if index is not equal to value. If the code, so if the code comes here, execution of the code comes here, it means index is not equal to value. Okay. So now we can actually go ahead. So or else we would need actually if, else if, and then an else, right? Or else what will happen if you just have if else if, then the final part will always happen if you don't have continuous. If you have continuous, okay. So, but we don't need an else if, completely different, and don't I mean, if you put else if, then you don't even need a continue here. Then you just need a continue here. But I don't want if else. Yes, I would rather have some matching expression. Let's see if I can do that. But only in Rust that can happen. Here, I don't think so. Let's see. So you can do some select something, select of a value and see if it matches something. We'll figure that out. But for now, I'm just gonna not figure out. I mean, not go ahead and do fancy stuff. I'm just gonna figure out how to just implement what I just written here. So now we have a stop index, right? Which we create stop index and stop index to old value. So we create it here, right? Um, so it's gonna be this, and it's gonna be this stop point index, and then we're gonna have a loop here, right? So this loop stops when it just stops when the index and the thing are same. So we can either put it as that. Oops, I put the whole thing. Okay, it's fine. I will write this down properly, and so I can actually put this also over there. And yeah, so this is gonna be this. I can't put minus. What I can put in. Um, to mark this as traveled or visited and updated or gotten new value, right? Now we move on as this is marked as traveled to or visited and updated or gotten new. So we just put this and finally here I go ahead and do this. I don't need new runs this time, so I'm just going to get rid of news. I think that's good. And I don't need this. And I'll actually copy the previous one. Just like that. So this, right? I don't need this. Yep. And I don't need the us, or we can just say this is equal to value. Just see that. And then I'll just say, can I have a bottom arrow? Maybe I'll just do this. Oops. So, okay, minus value as non-index. So, yeah, and I'm just gonna go ahead and so we'll say this as top point, old value is old value or original value at stop point index, and we need the original value of terms of value, right? This is as so terms of index value. Thank you. So nums of index is value, yes. We can probably just put that here. I think everywhere I can just say value, but actually it's not. So value is actually nums of index. This is nums of index. Oh yeah, this can be value, but I'm just not gonna take it. I'm just gonna leave it for now, and I'm just gonna use uh, yeah, nums of index is value, but I'm just gonna say nums of index. Uh, I'll say AKA, but I'll just use nums of number of index, right? Nums of index, right? Um, so you just go ahead, you got the value. If it's not the stop point index, then you know that you are at somewhere else, and you can actually already. Uh, oops, wait, what is this? Why did I do this both times? Okay, I think I have done this 2 times here. Huh? Yes. I think I should just, yeah, I mean, this should happen only if number next is value, yes, and number next is value and number value is that. Only if the thing is same, so I have to know this, yes, and I can't just say loop, so I'll just say for here, and I can break like this, or I can break over here, right? So when I say index is equal to stop point index, right? But initially itself, I think it will be stop point index. So I don't want it to be. So if value equal to stop point, okay. We need to also say index is equal to value here, yes. Um, so yep, done that. And I mean, let me see. Um, is there any places where I've changed the value? Yeah, I think value is going to be tricky. Like, basically, it has to be if the index is the stop point index. So initially, so you cannot just put value everywhere. I think. Um, so value at index, right? And then you just say index is equal to stop point index. Yeah. Put the value here, but I think you can just put this as before you put this, you can just so you start off and initially the index will be the okay, not value. Oops, I think I made a mistake with value. I think when the value is stop point index. Okay, so this we'll have to figure out how this works. Like we have actually put it as like value doesn't keep changing. Ideally, we should change it here. So, for example, you start with say 0 and then 11, right? Or 1 and 11, and then you say 11 is not equal to 1. Okay. So 1 and 11, and you go ahead and give it the value, right? Like index 1, and this is 11. This is you get 11 here with the value, and probably 1 value, and I think the value there's going to be it's going to be a bit tricky because okay, so we'll say value is equal. So this is going to be 11. 11 is not equal to 1. Then we just go ahead and do index is 1. This is 1, and it's going to be 11, and then also 11 is 1. We'll strike it off with 1, right? And then we'll say it'll become -1, -1 is -2, and then index will get the value 11. Right? After this, um, Index will get the value 11. Um, so index is not the stop point, like it's not one, right? So when you go back, now you do value. You actually need to get the new value here of your index because the index is changing here. So you need to say um, when you change the index, you need to change the value also, right? And value equal to nums of index, right? And once you do this, um, you can do this, or you can use a value only over here, like value equal to like you can just say nums of index everywhere, and you can just say yeah, you can do that. You can just say nums of index everywhere. That's better instead of saying value. I think that is better because you need the new index, and it's better to just use nums of index, right? And just use nums of index everywhere because of this problem. Because when you update index, you also need the updated value. Just say this. Oh, okay. So you can't use this because this just got mixed up, is it? Because it was one letter. So let's say it was 1 and 11. Start from 1 and 11 value. You say uh, index is 11 equal to 1, no, not equal. So finally we say number of index is 1, at 1 you have 11. So you just put 1 here. And you actually need to capture the value here. So maybe, just maybe over here alone, maybe you'll just say nums of here. And I'll see this everywhere. Maybe nums of index is less than 0. It's better that way. Nums of index, right? Uh, is equal to nums of index, right? So there is no value over here anywhere, right? Okay, so we don't need this. Is there anything like that? Value, okay. Good. The resume means that index is not equal to the value at index, right? At index, right? And once you get this, now you check this, yes. But the tricky thing is, I think you'll need to keep the old value first before you override because you will need this old value. Like, you actually change before changing, you need to keep the old value. You need to get the old value before changing it, right? So before changing it, you need to take the index. So in 111, you take the index, the value, and then you change it to this, right? So, and you're changing it here also. Okay. Hmm. Okay. So one moment. So if it's numbers of one, uh, this is basically numbers of one, and you say, um, you know, get the value at the index, and this is 11. It's not equal to 1, and just go ahead with this. This is 11, another one is 1, and but you actually need to go to 11, I think, because this becomes 1 and then becomes minus 1. Before this change, you need it. even here, if the number of index is equal, so before this change you'll need it, I think. Before this change you'll need it because now you're gonna put this in, right? In num of one you'll put num of one is 11, num of 11 is 1, and you just put 1 here. Before this change, you need to say it's going to 11, and then finally you find out you do this, right? And 11, so index is 11, stop point index is 1, so no, it's not equal. Finally, you do now number of index, this is 11, equal to 1. I mean, this is 1, yes, it's equal to 1, yes. So then you actually put the value over here, num of 11 as original value, which is the stop point index fold value, right? And then as no, as number is equal to value, maybe I have to say something like number of index, but that's clear here itself. But before you do this, I think as is the old value or original value at stop point index, and we need the original value of nums of index, right? Nums of index, right? So we want the original value, not the overwritten one with a negative sign. Okay, so you stop here. This is why we store the old value so that it can be retrieved later. This can be called as the loop point index because we expect a loop actually here, right? Loop or cycle point index can also be called as start point index and start point index old value. Uh, can also be called loop or cycle. Now let's time instead of start, stop, start, visible. Because this is where the loop is happening, right? So it's a stop point index value, you stops here, right? So you break out of the loop. You can actually mention it here, but we want it to go through the loop once at least. If you mention it here, it will just stop immediately. It will go through the loop, yes, and after once it enters, it will keep looping until it comes back to that. So the thing is, interesting thing is this. So here we have nums of 11, which is, I mean, nums of 11 is 1, so top point index is 1, right? Assuming this is 1 and 11, right? 1, nums of 11 is 11. So 1, 11, 11, 1 concept where 1 is the index, 11 is the value, and 11 is the index, 1 is the value. In this loop, what happens is you get the old value, which is 11. So you put nums of 11 is 11, right? And then now your index is still 11, right? It has to go back to 1. So before itself, you put that actually. You say index is equal to nums of index, right? So that you've already gotten this. So maybe before you do anything, okay, actually you can't change the index because You need it here. Once you use it here, I think you can update it. And here the update surely happens. You can't update it already because it's happening. Basically, this is the only place where it's happening, right? So you update the index. You say in nums of lemon is basically one, or basically the stop point index, right? And finally, you come back here and you say break, or you can actually break here itself, right? You can actually break it here itself. You can just say old value and just break it here itself. You don't even have to do this, right? So this is one version. I think reducing code is better, right? So I would rather just um, break the loop here itself than look for if index equal to after putting this value, the basically that's all you need to do, right? You need to update the index and then you break it. So index becomes basically nums of index is basically top point index, right? Which is 11. Index 11, nums of 11 is 1, which is the same as this 1, and nums of 11 is 1, so we will put index is 1. Later, oh, you don't have to do this, by the way. And you put the stop point old value. Oh, yeah, you shouldn't do this for this one though, should you? Oh, you need to do this because this is still actually a what do you say, positive value. You still have to do this, and then you stop, right? So you can break out of here, but you'll miss these, right? So you need to do this, and you need to break in case it's equal. So yep. So these are the two things that you need to do, and you need to do this index thing. If you do it before, in case it's needed here, it's a problem, and if it's not needed here, it will be needed here for because first check, then only it will be used here. It'll be updated after this. So you need this check and then only you can do this. So you can't help this. Um, so yeah, I think with this the code should just work. Let's see if it works. Did I make this? Oh, I actually missed to put I plus plus. I think. This will keep looping around. I think. Let's see how it works. I think this will keep looping around because I didn't put a I plus plus or index plus plus at the end because index plus plus we are doing it over here only. Have I done an index plus plus at the end over here? No. Actually, after this for loop, I should do an index plus plus. Once it breaks, I have to do an index plus plus, but I didn't do it. Let's see how it loops. I think this will just keep going on. Oh, we have. Let's see. It says this error in this case input output is -1. Oh yeah. Looks like it did work. There was no loop here, right? So that's it. So I do have to make it positive finally. So I'll do that. So I can actually just do for a range here. But then range will actually go through each and every index by itself. I don't want that. And it will run for every index, but we're sending an index in between itself. So this is fine. I can use range. So I can use for index comma or value range nums. I can basically say value. Oh, I do need the index because I can't just say value equal to 1 or something. It will say value is declared but not used, value -1. But it won't update this value again. So this value of so this value is never used in like this is not using it. So I would rather say index. then say nums of index is equal to minus value minus 1. Is that right? Am I? Yeah, this minus happens. So is it right? Because if it's, let's say, minus 1, it's plus 1. Minus of minus 1 is plus 1. So it's y is equal to minus x minus 1. So you put minus 1 on the other side. So it's minus x is equal to y plus 1, and x is equal to minus 1 minus 1. So yeah, that's the value. This should go in a loop because I haven't done. Oh, wait. Nums of, wait, what happened here? Index out of range, minus 3 recovered. So this is in test 2. Okay. So I think somewhere I made the mistake of putting or using minus 3 as index. I think I just didn't do plus plus. That's the problem, I think. For test 2, so here if you notice this is 0 0. This one went along fine, right? So I didn't do plus plus. Now what happens is this probably became 2 1 1 2. Finally, what happened is 0 1 2. So 1 1 and 2 2 1 1. 2, the 2 became minus 3, and you know, ideally should have gone and found the thing, and it says value is minus 3, but the value is negative. Okay, I should have checked if the value is negative, right? I checked it, index plus plus. The value is negative, it's index plus plus, okay. Um, so here I do that, minus 3, and then I go to this. So it's negative, I go here, so 0, 1, 2, 3, right? So I go here, it's 5, 4, 4, 3, 3, 5, and interesting, 5, 4, um, 4, 3, 3, 5, and come back here. This shouldn't have happened in this case though. 0, 1, 2. I wonder why it happened here. 0, 0, okay, index plus plus. And this one, we didn't do index plus plus. We put it here, and then but the value was negative, so we just did plus plus. Value was negative, we did plus plus. Hmm. I wonder how that happened. Because ideally, we had gone back here to the same index, you stop, and you have negative value. So, oh, you can't actually. Oh, wait. Index has become negative. Index shouldn't become negative. Let me see what is the index. 20.printline. What is the index? Index. Index is index with a new line. Let's see how that goes. I think somewhere I'm actually making a mistake of actually. Where's the index? Index is 0. Index is still 0. How come? Index is 0. Okay. Index is 0. No, it's equal. So in this case, I think I want to check only for. Okay, for this one it's 0 and then it's 1, 2. It goes back to 0. Why is that? 0, 1, 2. Is this for test case 2 or something else? I wonder. Is this for test case 2 only a thing? So it happens here in line 69 over there, in line 46 over here. So it says index is equal to this nums of index. And okay, so let me find out. So let me just put this. I haven't put index plus plus number, but I understand. Wait, let me put the statement here. I want to see where are the stop points actually. And so if the value is not equal, so you have a stop point. Stop point index and its value is D and terms of index, right? And print the index here. Index in the inner loop is this, right? So percentage index, oops, sorry, index, right? And let's do this again with this run. So this is happening how stop point index and its value is 1, 2. Index in the inner loop is 1, and then the index in the inner loop is 2. Okay. And what happened here? So it's basically, I think this one. Top point index is 1. Okay, yeah, this one. The value is, and its value. Value is 2. How? Are we talking about some other thing here? Hmm. I think I might have to run these test cases separately or something. I'm not sure which is actually failing, so I might have to run these separately. I just want to go ahead and comment this out and see if this works. This is okay. See if this works. I think this itself is failing, is it? No, it shouldn't be failing. This is fine. This should be fine too. I wonder how it ended up that. Yeah, in our stop point index and its value. Did I say nums of index? Yeah, index and nums of index. 1 and 2. How come? How come the this 1 and the value is 2? How? 1, 2, okay. This is not the stop point though. This is the stop point. Oh wait, index is 1. How is this 2 though? I don't know how this is changing. And it says index in the inner loop is 1 and then it's 2. Okay, I'm gonna debug this in some time. Let me just pause this for a moment. Or I'll actually stop this and I'll actually record another video where I'm debugging this. That's all I have for this video. I'll see you next one. Bye.